Chapter 5, Section 1 is about identifying linear functions. And our first definition is linear function. A linear function is a function that is a line. So it has to be a straight line. And it has to be a function. In order for it to be a function, it needs to pass the vertical line test, where you can take the line and pass it over. If it only touches in one place the entire way, then it is a function. So looking at this first one, it is a line, it is linear, and if you do the vertical line test, it only touches in one place. So yes, it is a function. If you look at number 2, first of all, it is a function. It only touches in one place. But this one is not a straight line. So yes, it is a function, but it is not a linear function, because it's not a straight line. Number 3, this is the line we're looking at right here, straight up and down. It is a straight line, but when you do the vertical line test, this is not a function. So this one is going to be no. It's not a function because each x picks more than one y. Number 4, it is a straight line, and if you do the vertical line test, it is a function. So this one would be a yes. And number 5, it's not a straight line, and as you do the vertical line test, it's not a function. So this one is no in both cases. As you look at examples 5, 6, and 7, we do not have graphs, so we can't do our vertical line test. We can't look at the picture and see if it's a straight line. So there is a shortcut to see if the data, a data table like this, represents a linear function. And the shortcut is you need a constant change in x and a constant change in y. So the difference in all of your x's needs to be the same. The difference in all of your y's needs to be the same. The change in your x is not the same as the change in your y. Your x's might change by 5, your y's might change by 2. As we look at example 5, we have -10, -5, 0, 5. From -10 to -5, we have added 5. From -5 to 0, we have added 5. And from 0 to 5, we have added 5. There is a constant change in our x. Each of the x's changed by 5. As we look at the y's, from 10 to 4, you subtract 6. From 4 to 2, you subtract 2. Our first set of y's changed by 6. The second set changed by 2. So that's not a constant change in your y. So that is not a function. Number 6, -4 to -2, we've gone up by 2. -2 to 0, we've gone up by 2. 0 to 2, we've gone up by 2. And 2 to 4, we've gone up by 2. So our x's, there is a constant change. Y's, from 13 to 1, you subtract 12. From 1 to -3, you subtract 4. Kind of hard to see here. You have a change of 12. You have a change of 4. That's not the same each time. So this is not a function. Your x's change by the same amount, your y's change by different amounts. And number 7, our table's going up and down rather than across. From 2 to 3, we have increased by 3. 5 to 8, we have increased by 3. And from 8 to 11, we have increased by 3. So our x's, that is a constant change. On the y's, from 4 to 3, we've subtracted 1. From 3 to 2, we've subtracted 1. And from 2 to 1, we've subtracted 1. Constant change in our x's, constant change in our y's. So yes, this one is a function. On the next page, linear equation is an equation for a line. And we are going to have 3 linear equations that we're going to look at this chapter. Linear equation is an equation for a line. And the first one we're going to look at is standard form, which is ax plus by equals c. Notice the x and the y are both on the same side of the equal sign, and all that's on the other side of the equal sign is this number. Number 8, we are asked to write this in standard form. 2y equals negative 3x plus 7. Well, we need to get the x and the y together. So we are going to add 3x to both sides. And if we do that, we have 3x plus 2y equals 7. The x and the y are both on the same side. And from there, you're also going to be asked to label the a, b, and c. A is the first number, the number that's in front of the x. B is the number that's in front of the y. And then c is the number that's all by itself. So ax plus by equals c. And then in the example number 8, the a is 3, the b is 2, the c is 7. 9 through 12, we need to just say yes or no whether these are linear equations. And if they are, we need to give a, b, and c. Number 9, they start out, it's in standard form. 4x plus y equals 10. So yes, this is linear. A is the number in front of the x. The number in front of the x is a 4. B is the number in front of the y. The number in front of the y is a 1. And C is the number with no letters behind it, and that will be a 10. Example 10 is 6 over x. Since the variable is on the bottom of this fraction, that one is not a linear function. Number 11, this is a linear function. Right now it's not in standard form. To put that in standard form, we are going to subtract 5x from both sides. And we then have negative 5x, subtract y equals 0. And the a is the number in front of the x, which will be negative 5. The b is the number in front of the y, which is negative 1. And the c is the number, which is 0. And question number 12, is that a linear function? You have this to the second power. That makes it so it's not a linear function. That is actually a quadratic, and that will be a parabola. So that one is a no or not.
So is 11 linear?
11 is linear, yes. This first one should say x-intercept. The second one should say y-intercept. The x-intercept is the point where the graph crosses the x-axis. The x-intercept is the point where the graph crosses the x-axis, and the y-intercept is the point where the graph crosses the y-axis. So point where the graph crosses the x-axis is your x-intercept. Point where your graph crosses your y-axis is the y-intercept. Now let's look at this picture right here. This is your x-axis. So this right here is your x-intercept. X-intercept, that's where it crosses the x-axis. So your x-intercept right here will be -2, 0. Your y-intercept is up here where that graph crosses your y-axis, and that will be 0, 4, like 0, 4, and that is your y-intercept. Notice your x-intercept, the first one is a number, the second one is a 0. So up here by x-intercept, let's write x, 0. Right here by x-intercept, write x, 0. And by y-intercept, write 0, y. And if you ever can't remember that, you can kind of reason it through. Crosses your x-axis right here, and this is -2, 0. So for your x-intercept, it's your first one that is the number. Your second one, that is the 0. Number 2, we don't have a graph to go with it. What we're going to do is we're going to substitute 0 in. We are going to put 0 in for x, and we're going to figure out y. And then we're going to put 0 in for y and figure out x. If we put 0 here in place of x, -3 times 0 is 0. And 0 plus 5y is 5y. So if we put a 0 in here, this whole first part cancels out because it's just a 0. And then to figure out what number goes in here for y, we can do 30 divided by 5, which will be 6. So that will be our y-intercept. And now we can do the same thing right here for y being 0. 0 times 5 is 0, plus -3. This whole thing cancels out. And you are left with -3x equals 30. To figure out what the x is, you can do 30 divided by -3.